Hello, this is Tony Nichols, co-founder and CTO of Great Ideas. And in this video, we're going to be looking at pragmatic ways to use cloud file storage in your enterprise applications. And we're going to be implementing some examples using the Great Ideas TrellisSpark platform, which is built on Blazor and Azure. So in this video, we're going to look at what do we mean when we talk about cloud file storage and how should we use it. We're going to have a talk about some of the example technologies that are involved in cloud file storage, and we're going to look at some of the common issues we've seen in implementation of projects over the decades in ways that people have tried to connect to cloud file storage in the past, which have introduced vulnerabilities into their applications. We're then going to do a demonstration of how the TrellisSpark platform uploads files from Blazor WASM components into Azure, and we're also going to look at how to download files from cloud file storage into our Blazor components. And then we'll do a quick summary and just cover why we think that people should be adopting this basic enterprise architecture approach. So let's start by talking about what do we mean when we talk about cloud file storage. So essentially, a user is working on a device, a client, using either, say, a Blazor WASM assembly through a web browser, or they may be on a desktop or a tablet or a phone, and they have a file on the device in the file system on the client application, and they have a file in the file system on that client device that they wish to upload to cloud storage. And they're doing that through a client application which is sat on that device. So in the top section of our diagram here is our folder structure with our files on the device. Here is our user interacting with a client application on the device, and they want to send files into cloud file storage. Now, as a best practice from an enterprise architecture perspective, we are recommending that instead of connecting the client application directly to cloud storage, that we use an intermediary web application to act as a buffer between the client application and the cloud storage. So when we're talking about cloud storage solutions, what are we talking about from example technologies? So Amazon, Azure, and Google Cloud Platform are common examples of public cloud storage solutions. And they provide solutions that allow you to provide a public storage solution where anybody can access any of the files in a particular container, or private storage solutions where only restricted users can access the files in the storage containers. So when you're thinking about public cloud solutions, bear in mind that even in a public cloud storage solution, you have the ability to say that this particular area of storage is private and can only be accessed by users with this SAS token or key and is not available to everybody in the world. Now, that's public cloud, but we also have the concept of private cloud, where people are basically building storage solutions either on-prem or within a data center provided by, let's say, a telco. And essentially what they're doing is they're basically creating a set of file servers where the files are being uploaded onto a file server, and then that file server is accessible to the client device through an intermediary web application. There are a bunch of associated technologies that we will cover in a technology video later in this course. Over the decades, we've seen a number of issues with implementation of cloud storage and storage to file shares. One of the biggest problems is the fact that clients are trying to connect directly to the cloud storage. Now, while that makes sense, if all the client is trying to do is download a publicly available file from publicly available cloud storage, it doesn't really make sense in any other scenario. So if all I need to be able to do is go to a public cloud storage and say, here is my URL, get me the resource, and there's no security, I don't really care, I'm just going to get the resource. So let's say, for example, it's an image file of a social media site. You know what, that's great. You know, client can connect and use that URL directly, and we're happy with that, right? But most of the other use cases, the client should not be trying to connect directly to cloud storage. So for example, if the client needs to upload a file to cloud storage, we probably shouldn't be letting the client connect directly to do that, because otherwise any client could put any rubbish into your cloud storage solution for your enterprise, and you can just basically get your enterprise cloud storage flooded with garbage from all other sorts of sources, and then you don't really have any control about what's being uploaded or the quality of the data that's being uploaded. So what we want to do with our enterprise cloud storage is secure access. So at least if somebody's trying to write information to our cloud storage, that only certain users are allowed to do that. Now, the other side is that we may be using public cloud storage or file shares or whatever, but the content that we're providing there, those files that we're uploading, maybe they are only accessible to a subset of people, so members of a particular website or users within a particular organization. We want to make sure that we have got some sort of security on our cloud storage. And one of the big problems when the client tries to connect directly to the cloud storage is that we must have put that connection information and secret information on the client itself, enabling the client to connect and authenticate against the cloud storage. And as soon as you put that information onto a client device, then you're opening up a security vulnerability. Somebody can go in and hack that device, access your connection and secret information, and can then gain access to your enterprise cloud storage. So that is a huge problem that we want to address with our enterprise architectures going forward to make sure we close out that vulnerability. So it should never be the case that you want a client connecting directly to your cloud storage, because you're basically just making that connection and secret information essentially public. It's not a good idea. Now, the other thing that's happening when we're doing this is that we have lots of applications, and every application is essentially hard coding against a corresponding service. Now, that again is a problem, right? Because we're not really maximizing code reuse. We can't really guarantee a standard implementation or a set of libraries being used, and we can't guarantee that we're going to be implementing common best practices and patterns that we should really be using in modern applications. So one of the problems where we don't have an intermediary application and the client is either trying to connect directly to the cloud service or each application is basically doing a different way is that we're not really taking full advantage of code reuse, standards, and best practices. So what we want to try and do is have a common pattern that we use for our client applications connecting to our cloud storage. And this is why we recommend that up here where we have our client applications, that instead of those client applications being able to access the cloud storage directly, we stick in an intermediary web application so that we make sure that we standardize all of the attempts for our client to download or upload a file through a standard web API, and that within that web API, we implement a set of standards and best practices to make sure that the quality of the files being stored in the cloud storage is protected and is having appropriate security policies applied to those files as they are uploaded and downloaded to our client applications. So all that being said, we're going to do a demonstration now where we're showing how the Trellis Spark platform uploads files through a web intermediary to cloud storage. For these demonstrations, we're going to need some cloud storage. So I have created a private cloud storage account in Azure called Trellis Spark Demo. To connect my Trellis Spark Demo cloud storage into my Trellis Spark environment, I've gone into my systems administration workspace, and in the storage section, I have created a storage instance called Demo, and my demo storage is a Azure Container and Blob storage marked as private. And as you can see, I have Amazon S3 and Azure File Storage, Google and local storage and SharePoint storage and so on. So I've got a whole bunch of different storage providers available out of the box inside Trellis Spark. And this illustrates the point that we were making, that the implementation of the storage is completely separate and distinct from the client's experience of the storage. So let's see how this is going to work. And so in this particular case, my demo storage is linked to an Azure Container and Blob. Here is the URL that gives me the root of that storage, and here is the connection string and secret information that allows my web API to connect to my cloud storage. Now note, this information is never really going to be sent to the client. So the client isn't connecting to the cloud storage. It doesn't know what the connection string, what the secret is. That's all held in my internal environment behind my firewalls in my web API configuration. Now let's go and have a look at how that would be configured inside Trellis Spark. So in Trellis Spark, in my user experience creator, I can go to my test functionality here, and I have created a test upload concept with a field called test cloud file storage, which is an upload file component. And we will look at the code behind this in a minute. But essentially what you can see here from a configuration perspective is I'm just saying that I am going to create records of type test upload, and part of that record will be an upload file component where I am going to store the information in my instance in an XML element called test cloud file storage, and I'm going to link that to the demo storage that I created in my workspace a minute ago. So this is how everything ties up, right? So I have a field called test cloud file storage on my instance record. That instance record is saying that the storage, as far as the client is concerned, I'm going to upload and download files from a storage account called demo. And then my workspace knows that demo is the thing that's going to map to my cloud storage. So here, this is the demo mapping to my cloud storage, and my cloud storage is over here. Okay, so this is the initial configuration and setup. So let's proceed from here to actually look at how this demonstration is going to work. Okay, so now that we've got the configuration complete, let's actually give this a try and test out, see what it does. So let's start by having a quick look at the code. So essentially what we're going to be using for our upload file component is we're basing it on the input file component. And what's going to happen is that when the user selects a file in the input file, the onChange event will fire, which will call this load file command to execute. And the load file command essentially is going to take the input argument here, and it is going to read the file from the file system, convert the file into a base64 string, and then upload the file to cloud storage. And this upload file is actually making an asynchronous call to our web API, and it is the web API that will actually transfer the file from the client to the Azure cloud storage. So let's see how this works in practice. So if I come here and say add a new file, so a simple example, I'm now going to choose a simple test file that I created earlier. Okay, so it's fired as soon as the file is selected. This load file command is being executed. As we said, we're going to use the input arguments. So as soon as the file was selected, the load file was called. And now we're going to basically read the file that was selected, and we're going to basically set up the file name and file type. We're going to reposition the pointer and convert the file into a base64 string. And what we can do now is we can then upload the file into our REST API. So we've set some breakpoints in the REST API, so let's just hit the continue button here. And we're now uploading the file. So let's see what this code looks like. So in here, the first thing we want to do is decode the storage information. So in the move to GUID field, I've been given the 6B334, which is the GUID of the storage that we're going to basically use as the target. So essentially what this is doing here is this is going into the database and saying, what is the configuration of this demo storage? How do I know how to connect to it? What secrets do I need to specify? Now what we're saying is, great, I got my storage. Now let's take the file string that I've been given as a base64 encoded string for my client and convert it back into a memory stream, so I've actually got something I can upload. And now what we're doing is we're creating a storage information construct that encapsulates all of the information about our request to save the file. So essentially all this is doing is putting all this together into a record format that I can now call my storage function to save this. So at this point, I'm going to my cloud storage to actually save the file. Now here, what we're doing is we're coming into our function that allows us to save. And at this point, we don't really know that we've got a Google or an Azure or a AWS or whatever. I mean, all we've got is basically a definition of take this file from my client. This is the storage definition. Please go and figure out how to store this file. So what we're doing inside here is we're looking for a few things. We want to make sure that we know what the workspace GUID is, and we'll see how that relates to creation of containers in a minute. We want to know what the instance GUID of this new storage record is, and we want to check to see that we actually got a storage definition. So at this point, what we're doing is converting that storage definition to XML. And if we open up this XML, we can see that this is the same XML that we had in our demo configuration. So this is basically the record that we created inside the workspace when we created the storage for demo. It's connecting to our Trellis Spark demo blob core storage. Now at this point what we're doing is saying, right, I now need to know what I'm actually dealing with, right? Because I'm going to make a connection now to my cloud storage. What is it? So at this point, we have determined that it's an Azure Container and blob and it's private. So I'm saying that my storage information is file public, false. No, this is not a public file, this is a private file. And now what I want to do is I want to go and save this blob into Azure Storage. So let's go and have a look at that. So if we step into here, great. We know at this point that our storage information contains a file. We know what the definition of demo is, and we're going to save it to Azure Cloud Storage as a container and blob. So what we need to do now is we need to go through our storage and we need to extract our connection string. We need to figure out what the container name is going to be. And this is where we wanted that workspace GUID, because what we want to do is we want to create separate containers for all of the files that we upload into a workspace. That way we've got a nice simple breakdown that we know that even within our demo workspace, any files that were uploaded as part of Server Owner or Great Ideas or whatever workspace is in a specific container. So they're all nicely encapsulated. So we're going to use our workspace GUID in our particular examples as our container name. So at this point, I've got the name of my blob. And what I want to do now is I actually want to go into my cloud storage and see what exists and what doesn't exist. So what we're going to start by doing is trying to hook up a container. And then we're saying, if that container does not already exist, create it. So let's go and have a look and see whether or not we've got a container yet. So if I go back to my storage and check here, you can see I don't have any containers in my Trellis Spark demo. So let's go back to my code and I'm going to step over here. So if the container doesn't exist, then create it. So if we go back and have a look now, what we should see is that we now have a new container. So this is the container for this particular workspace. Okay, so this is good. And then I'm going to decide, is the file public or not? Well, the file in this case is not public. We said this is private. Okay, and you can see if it's going to be public, then we're going to set the access policy as being public. And if it is not public, then we're going to set the access type to none. So here, we're going to go down this path here. Blob can only be accessed by the owner or somebody who has the appropriate credentials. And at this point, we're saying, great, the file URL is set and good to go. Okay, so if we have a look in our containers at this point, okay, so at this point, the file has not yet been uploaded. We've got the container within our storage, but now we actually need to upload the file. So let's have a look at our code here. So at this point, we've figured out what the file URL is going to be. We've decided that the access policy on the container is that there will be no access. And so the next thing that we're going to do is we're going to come down here and we're going to get a blob client for the container. And we're going to basically start by deleting the blob if it exists. So this basically will overwrite any existing blob of the same name. And then assuming that we're in a position where we're now ready to write the blob, we'll reposition the memory stream at position 0. And at this point, we're going to write the blob to cloud storage. So one last quick check. If we go and have a look at the storage, we can see that we don't have any blobs in here at the moment. If we go into here and execute this, then this is the bit of code that's actually written the file to the blob storage. If I come here and refresh now, you'll see I have the new file in here. And if I click on this, you can see that the name of the file is the instance GUID of the record that contains it. It's picked up the X element name here for our Excel storage, and it's picked up our file name, which is basically our simple example. And that's all been concatenated together, and it's stored that file within our Azure storage. So for this point, we've now taken the file from the client, we converted it to base64, we sent that file to the web API. The web API has converted it back from base64 to the appropriate file type, and it has looked at the storage definition and said, oh, I'm trying to copy this to the demo storage. And in this case, the demo storage means just copy it to Azure Cloud Storage. And that's essentially what's happened here. Let's continue through to our user experience and see what we are going to see in the UX. So at this point, we have uploaded the file into cloud storage and it has refreshed this component and read the file back. And we now have a download simple test file. So this is the thing that we loaded in the first place, or we can clear the file. So at this point, we have successfully uploaded the file. In this second demonstration, we're going to look at the reverse process. So in demonstration one, we uploaded a file into Azure Cloud Storage. Now what we're going to do is a controlled download of that file back to our client application, again through our MASM client. So in the first demonstration, we configured our cloud storage account in Azure Cloud Container and Blob Storage, and we uploaded a file to it. So now what we're going to do is the converse. We're going to open an instance where we've previously uploaded a file, and we're going to get that file from our cloud storage and make it available to our client. So let's have a look at how that works. So here's our simple example that we loaded in the first demonstration. And when we click here, we can see that as we go into the instance, the first thing that happens is we go into the form builder, which is going to try and basically figure out which fields we need on the form that we're going to display. So this is happening before the form is even being rendered. Okay. So what's happened is we've identified the fact that we have an upload file component on here, and we're starting to decode what is actually associated in that upload file. So has a file already been uploaded or not? So we've got basically our storage definitions. We've gone and basically pulled the storage data out of the configuration. So at this point, I know what sort of storage I'm dealing with. And now what we're going to do is we're going to have a look and say, okay, great. Is there some file in the cloud storage that we need to download and present to the user? So essentially what we're doing here is we're working through, we're defining some basic information about the storage, and here, for example, is the instance GUID and element ID and the simple test file name that we had that we uploaded in the previous demonstration. And here is our storage definition, and if we have a look at that, you can see again that we've recovered the storage configuration information that we saved under the name of demo earlier demonstrations. And now what we're going to do is we're going to actually read the file from the cloud storage so we can present it to the user. So let's step into this read file function. And you can see, again, first thing we're going to do, have I got a workspace? Have I got an instance? Okay, great. Did I get the storage definition? So assuming that all of this is coming back correct, then what we can do is say, okay, great. What we're going to do is we're going to see what sort of storage we're going to attempt to connect to. It's the Azure blob and container storage, as we wrote to in the first session. So this is all good so far. And then inside here, the first thing that I'm going to want to do is extract my connection string, my container name. So remember, my container name in this case is going to be my workspace GUID, and my blob name is going to basically be pulled out from the information that we were given, which is the instance GUID of the record, the XML element name, and then the name of the file that we actually uploaded. And then what I want to do is then connect to the container. So at this point, the container must exist. It should already be there. If it doesn't, it's a problem. Okay, so the first thing I want to do now is just test that the container exists. And assuming that the container exists, now let's go and have a look and see whether or not the blob exists, right? Because again, if the blob doesn't exist, then I've got a big problem, right? Because I'm trying to read a blob that doesn't exist. So assuming that my blob exists, now what I can do is I can come in here and I can download my blob. So at this point, what I've got is I've got a connection to a container, I've got a connection to a blob. I'm now going to download that blob. And then assuming that my blob has downloaded, I'm now going to basically say, hey, I went to the storage, I found my blob. There was no problem with that, so I'm going to reposition the pointer in the memory stream. And then I'm going to convert my blob into a base64 string that I can then return as part of the file. So here I've converted my blob to base64 so I can return it. And then I'm going to say, hey, I've got a file to return. I wonder. Again, one of the nice, cool things about centralized processing is that we can add things into that filtering pipeline. So in this particular case, if I was uploading, let's say, an image, I might want to be able to display a thumbnail. So what I'm doing in this particular step is saying, well, okay, go and have a look at the file that I've just pulled down. And if it's an image, give me a thumbnail as well. In this particular case, it's a simple text file, so there will be no thumbnail. So we'll just skip over this. And at this point, what we've now done is said, hey, great, we've got our field definition. It's going to be an upload file. Here is the file that was uploaded. So if the user wants it, it's going to be immediately available to the user. We don't have to go back to the storage to get it. It's already there. Okay. And so here, if we just hit continue. So at this point, we've entered the instance. We have extracted all of the instance data, all of the field definition information. And in this particular case, we have also downloaded that stored file behind the scenes so that when we come in here and click on this control, the file is already there. All I need to do now is run through a JavaScript runtime interop to actually make that available and copy that file into the download folder for this particular user. So at this point, if I come and have a look at my downloads here, you can see that my simple test file has now been downloaded and is available to the user. Okay, so far we've taken a file off the client, converted it to base64, sent it to the web API. Web API has converted it back from base64, saved it to the cloud storage that we've defined in our configuration, and then reversed the process to bring the file back to the client. And that was simple and straightforward. But part of the process of putting in this web API is that we've now introduced a pipeline where we can put additional processing in place. So let's have a look at how we might exploit that as a practical example. So what I'm going to do now is I'm going to upload a picture. So I'm going to basically take a picture of a puppy and upload a picture of a puppy to the solution. So what's happened now is the picture of the puppy has been uploaded, and now we're refreshing our instance page. And as we refresh the instance page, you'll remember we've taken the file out of Cloud Azure Storage, we've brought it back to our web API as part of refreshing our client. And at this point, after we've detected that we do have a file, what we can now come and do is have a look to see whether or not it's possible to create a thumbnail from the image. So what we're going to do is we're going to come into this function here. This is something that we stepped across in the first example because it was just a simple text file. But now let's drill into this and see what we're doing. So here what we can do is we can say, hey, did we get a file? Yes, we did. Okay, great. Was it an image? Well, you know what? Yeah, you know what? It's a JPEG. We could get a thumbnail out of this, right? So what we're going to do here is we're going to basically look at that file stream and we're going to load it into an image control. And essentially what we want to do with that image control is see whether or not we can convert that into a thumbnail. So let's stick some more breakpoints in here and we work our way through. So we've dealt with any orientation issues. We've decided how big we want our thumbnail, and what we want to do is preserve the aspect ratio of the image. So as you can see, right, we've got some very sophisticated processing coming in here from the file that we've just read back from cloud storage, but before we send it to the client. So obviously we could be doing all sorts of things here. We could be doing compression, we could be doing encryption, or we could be logging data, doing data loss prevention, and all sorts of other fun stuff. But in this particular case, we're just going to take a thumbnail of the actual original JPEG and save that into our returned user experience. So that when the user experience returns, what we're going to see here is a thumbnail of the image that we originally loaded. So this thumbnail was created on the web API between the point where it was read from the cloud storage, the API got the file, the API converted the file into a thumbnail and saved that and returned both the original image and the thumbnail to the client. And so our upload file control on the client can render the thumbnail as well as having the actual original image available here. So if I click on the download images, I can see that here is the original image that I uploaded. So this demonstrates one of the core advantages of having this intermediate web API that sits in the middle. Right? We can actually read the file before we render the user experience, and we can process that file and make it available immediately to the client. So as soon as the client wants to click the download button, it's there, it's immediately available to them. So in summary, why do we recommend that you adopt this approach in your own enterprise architecture? Essentially, you do need to have some sort of mechanism for accessing cloud file storage. I mean, everybody is going to want to save files at some point and read those files back down. From an enterprise architecture point of view, having a solid pattern for cloud file storage is something that you are going to want to adopt. And the reason that we promote this idea of an intermediary web application between our clients and the Cloud File Service is that we then provide a standard mechanism for uploading and downloading files, irrespective of the cloud service provider that sits in the back end. So in the client is saying just upload or download a file from this storage, and it doesn't know what that backend storage is. It doesn't know whether it's AWS or Google or Azure. It just says, save the file here, read the file from here. So from the perspective of the client, we just have a standard mechanism of saving and loading files. And then from the web API perspective, we now have a central point of control for all accesses to files between our clients and our cloud storage solution. And this acts as a point where we consolidate the connection and secret information so that we never have to pass that information to a client. The client just says, save the file in the documents location, save the file in the attachments location. And then the web API says, hey, I've got a file, it needs to go into the documents location. Well, what's documents configured to at the moment? Well, it's an Azure storage area and it's a container blob and it happens to be private right now. And these are the data loss prevention policies that we need to apply, and it needs to be compressed and encrypted. And if we want to extend and introduce more sophisticated storage patterns, we can do that within the context of our web application, removing the file from the client as we upload it into cloud storage. And then as we pull it back down from cloud storage, as we download the file from cloud storage, then we can reverse the process. So if our storage requires a particular encryption pattern or a compression pattern, then we've uploaded it, we've applied the encryption and the compression as we've put it into cloud storage, and then as we download the file from that cloud storage, we can reverse the encryption and compression to provide the raw file back to the client. So this gives us a really good point of control within our enterprise architecture that decouples all of the clients that need to use cloud storage from the actual implementation of the cloud storage, and make sure that that centralized web application can implement all of the best practice storage patterns that are appropriate for each of the different cloud storage options and scenarios that our organization needs to cover.
To learn more about Great Ideas products and solutions, visit greatideas.com. That's Great Ideas with a Z.com. Thanks.